video for Chapter 3 using GeoGebra spreadsheet analytics to find statistics for some scores. So we're going to click on that link just like we did in Chapter 2. We're going to go into the apps and then down to View. We're going to turn on Spreadsheet, turn off Graphics and Algebra. We're then going to paste that data, I believe these are scores, examples from the workbook, into column A. Now I want to show you how to use a command in GeoGebra. It's fairly easy to see that the mode is 8.2. It appears twice, but let's use the power of this spreadsheet to do that. So I'm going to label the next entry mode, and then I'm going to enter this twice. So the first time it's not going to work, so I'll talk through it a little bit quicker the second time. Notice that I pressed equal sign, typed in mode, and then entered that range inside of parentheses. When you press enter, it disappears. You go back in and it's purple. Now we press equals MODE, then an open parenthesis. Notice that a close parenthesis also appears. I'm then going to select probably more data than I'll need, but that will allow me to change and add stuff to illustrate how this is dynamic. Press enter and I get the curly braces showing me that the mode is 8.2. That's because it appears twice. Now because I took the range for that mode function down to 20 something, I could add some more values. So if I add 6.8 for example, now there are two modes. This is bimodal, 8.2 and 6.8 because both of them appear the same number of times. If I add another 6.8, now the mode is 6.8. There are more 6.8s than 8.2s. So just showing how you can use commands in GeoGebra in the way that you would any spreadsheet. But of course what we want is the statistics data. So I'm going to click on column A, then I'm going to click on that histogram logo and perform one variable analysis. What I want to see is the statistics, so I'm going to go over to the sum of x logo, and I've got my statistics. Now, as a visual reminder of what's going on here, I'm going to also open a box plot in the graph. And that allows me to see what this data looks like in terms of how these numbers fall out in relation to each other. So let's go through this. There were 5 data points. The mean, that is the arithmetic average, is 8.02. If this was a population, we would have its standard deviation using that lowercase sigma. We're going to be using S for the sample standard deviation, so 0.9654. Here are some of the intermediate steps if you want to check your arithmetic computing this on your own. The minimum value was 6.8. That's also shown in the box plot as the single bar by itself on the left. The max, 9.4, is the single bar out on the right. That middle bar is the median, 8.2, and you can see that's exactly where it is. And then our first quartile, 7.15, is the left edge of the box, and the third quartile, 8.8, is the right edge of the box. That means that if you're wondering where the second quartile is, it is exactly the median, so right there in the bar inside the box. So here's our box plot showing us our minimum, then the first quartile, then the median, then our third quartile, and finally the maximum. And this is dynamic, so if you change stuff here, you can see what happens to the box plot and also to the data. If you want to undo that, you can. So let's take that back to 7.5. Okay, we'll also want the range and the interquartile range. Now you can certainly do this with a calculator. It's simple enough, but since we've got a spreadsheet, we might as well do that as well. The range is simply the greatest spread of the data, so it's the maximum, that is 9.4 minus the minimum, which is 6.8. So our range here is 2.6. The interquartile range is the range from the first quartile to the third quartile, so that's going to equal 8.8, that's our third quartile, minus 7.15, so the interquartile range is 1.65. Having an illustration here, this box plot is nice to distinguish statistics from ranges. Statistics like the minimum, the maximum, the quartiles are all on the x-axis, so we can see them lining up perfectly. And we remind ourselves that the ranges are distant, so how far it is from the min to the max is the range, the interquartile range. Of course, how far it is from quartile 1 to quartile 3. One of the things that is mentioned at this point as well is that the interquartile range contains half the data. And that's our first look at using the GeoGebra spreadsheet analytics to find statistics for us.